This lesson is on graphing. We're going to look at typical types of graphs you see in the Algebra 2 curriculum, as well as some terminology and some interval notations that we'll be using for this class. This lesson is from topic 1-1, day 1 of the Algebra 2 curriculum. First of all, I want to show you these two-column note format that we will be using in our class. It gives you the topics on the left, and then on the right side of the two columns, it gives the details. So if you ever have to go back and review over a topic, you can look for the topic in the left side and then look for the detail that goes with it. So we'll be using this as our typical format for our notes in Algebra 2. Now, we're going to start by reviewing over some graphs that you learned in Algebra 1. We're going to talk about graphing inequalities because we're going to use that in what's called interval notation. So first of all, the graph of 3 less than or equal to x less than 6. If you remember, when it has the line underneath it, that the or equal to means you put a solid dot because it includes it. So if I label this graph with a 2, a 3, a 4, 5, 6, and 7, we'll put a solid dot on 3, an open dot on 6, because when there's not the line underneath it, it means don't include that number as part of it, and then everything in between. So we fill in the graph in between it. So it includes the 4, the 5, but it also includes the decimals in between, like 3.9, 5.5, 4.2, all the numbers in between 3 and 6, including 3, but not including 6. So x is between 3 and 6, includes the 3, does not include the 6. Now, what if we only have x's greater than 4? So this symbol here, this is a greater than. So that inequality, when we number our, put in numbers, so I'll start with 0 here, 0, 1, 2, 3, 4, and 5. So at 4, we're going to go ahead and put an open dot because it doesn't include it, and then shade with an arrow saying it's every number greater than that 4. Now if we look at this one, this is a less than or equal to. It's got that or equal to on it. So the line underneath means we're going to include it. So I'm going to start this one maybe at 5, 6, 7, 8, 9, and 10. I'm going to put a solid dot on the 7, and then I'm going to shade to the left because that means every number less than it. Okay, so this one would greater than 4 would include like 4.8, 4.2, the numbers in between, 5.7, and like 100 or 1,000,000 is included in that. Whereas this includes all the numbers below 7 and includes 7. So like 0, -10 would be included in this inequality. This last one here, let's start maybe with 0 here, and I'll go with -1, -2, -3, -4, -5. And so I'm going to go greater than or equal to -5, 2, 3, 4, 5. So here, solid dot on the -5, and then shade in the greater than direction, which means to the right. Now we're going to use that information with interval notation, set builder notation in a moment. Let me talk to you about what those notations mean. First of all, interval notation, if I were to take an inequality such as this, let's say I had -2 less than or equal to x less than or equal to, let's say 10. I want to be able to put some shorthand to that. Shorthand meaning I want to write it quicker than that. We can use what's called interval notation, which means we can put the -2 and the 10 are the two important numbers there. And if I put brackets on it, that says let's make those including it, the or equal to. And so if I had a different one, like let's say I had 1, let's erase that. If we have 1 less than x, and let's say less than or equal to 7, then those numbers, what I would do is I'd put a parentheses next to the x, and on the 7 I would put a bracket because that would include the 7. This parentheses means don't include the 1. Now, remember in algebra, you used to do ordered pairs that represented x's and y's. That's not what this is. Remember, you gotta look at the context of something. In this context, it's saying only the x's are between 1 and 7. The bracket means include the 7. The parentheses means don't include the 1. So if you see a parentheses, this means that you're going to have an open dot on the graph. If you have a bracket, it means included, so it would be a closed dot. So not included, included as part of it, okay? Now, this shorthand we can use up here. Let's do each of these with this interval notation. So this one's gonna have a bracket on the 3, and then on the 6, it's gonna have a parentheses because it doesn't include the 6. Now this one, if you look at it, it's not gonna include the 4, that's where the interval starts, but then it keeps going off forever. It includes all the large numbers. Now, since it goes off forever, we say it goes off to infinity. That's what would be implied to be with that arrow. So since it goes off forever, we put an infinity, but you can't actually get to infinity. So we're gonna put a parentheses around it. You don't include infinity because you don't get there. So whenever you have an infinity, put a parentheses on it. Now this one, we end at the 7, so we're gonna put a bracket on it, but we go in a negative direction off to infinity, so we're gonna say it goes off to negative infinity with a parentheses on it because we don't actually get to the negative infinity. And then lastly here, we include the negative 5, so we put a bracket on it, and then we go off to infinity, and so we put a parentheses on the end of that one. So that's interval notation for those inequalities. Now we do have another type of notation that you will see at times. It's called set builder notation. It's a formal notation. So formal in that it's kind of, it's not the shorthand like we use here, but it's the formal way maybe a mathematician might speak in terms of using giving the information about the mathematics. So we do not use this very often, but you have to know how to read it because it might be given to you at times and you have to see it. So if we have something like this, the formal notation, all it does is it puts a brace on it. It then says every x such that, and puts a slash there, at 3 is less than, you just put this rule here, less than or equal to x less than 6, and then you put a brace again at the end. So all this is saying is, the way it's read is x such that, and then you give the rule that comes after it, x such that, let's see, we're less than 6 here. All right, so for set builder notation, you just give that rule. So I'm going to just rewrite the rule, put a brace at the end, and then just put an x with a slash in front of it, just show that notation. Now, mathematicians sometimes don't use the slash, they'll sometimes use instead a colon. So we could do this instead, and it means the exact same thing, slash or colon, same thing, put the rule afterwards. And then lastly here, or the last two here, we'll put x, and I'll do another colon here. X is less than or equal to 7. And the last one, just to emphasize that it could be either one, I'll put the slash for this one. X such that x is greater than or equal to, x is greater than or equal to negative 5. So that's the formal notation. Notice it takes longer to write it. So that's why it's nice to have the interval notation. That's a shorthand way of doing the problem. All right, let's take a look now at further down here. Let's talk about functions and their graphs. So a function, we want to define a function as for every input, the inputs being the x values, there is exactly one output. Just a little bit up here. Exactly one output, which is our y values. Right. So let's talk then about what sorts of information goes with these graphs. So when we talk about domain and range, these are going to be used all year long. So you have to get used to the phrases domain and range. The domain is all the x values, whereas the range is the y values. So with the x values, what you want to do is realize that we're going side to side with these. So you start here, you end here, what is happening side to side for the graphs. So the interval notation for this domain where does this graph start? Where does it end with the x values? So when we look at that, the x values here start at 1, 2, 3, 4, 5, 6, -7. So, and it includes it because there is a -7x value. This is a -7. And then for the y values, or for the x values, it goes all the way out to 1, 2, 3, 4, out to 4. And it includes that 4 as well. Okay, so all the way out here. So these ordered pairs, this ordered pair now is -7. The y value goes up to 1, 2, 3, 4. Okay, and the this is x and y now, not interval notation. So notice the context. This is interval notation for what the domain is. This is actually an ordered pair, an x and y, what those are. This is 4, 6. Notice the x value is 4, the y value is up here at 6. This other point here is, we'll just put it in here, it's at -3, -1 as part of that. Now, let's go ahead and talk about the range. The range are what happens up and down. So this is up and down. So when you look at the up and down, what is the lowest this graph goes to in interval notation? So the lowest this graph goes to is that -1 for the y value. The highest it goes to is that 6 for the y value. So it's going to go from an included -1 and go all the way up to 6 as part of where the y values or the range goes to. All right, intercepts. Let's talk about these now. Let's go a little bit higher here. So my intercepts, this intercept means where it crosses an axis. Okay, so we're going to go where the graph crosses an axis. Okay. Now, if you look at these, it crosses the x-axis here. Here's the x-axis. Crosses the x-axis at -1, 2, 3, 4. So x-intercepts at x equals -4, and also x equals negative 2. So I'm going to put a negative 4 here and a negative 2 where it crosses right here and right here. And then it crosses the y-axis here at y equals 2. So it's a y-intercept. At y equals 2 for that. Now the next thing we want to talk about are the positive and negative intervals. Now when looking at this, I'm going to raise it up just a little bit to see this. Where is this graph above the axis? So positive means above the x-axis. And the negative means below the x-axis. So when we look at this, when is it above? Well, notice it's above the axis for the x values from negative 5 to negative 4. A little bit more, negative 4. So where we have a positive interval, it starts at negative 7. And then notice that it goes all the way to negative 4, but negative 4, it's a 0 value. It is not negative, it's not positive. This positive turns into a 0 and then goes negative after it. So it's going to go down to negative 4, and we're not going to include negative 4 because it's actually an intercept. It's 0 there. Now there's another positive region here. It starts at negative 2 and it goes off to the 4. So another positive region is from negative 2, not including it because it's 0 there, and then all the way to 4 where it includes that one because it stays positive. And then our negative interval here, negative interval is between negative 4 and negative 2. So we don't include those because it's 0 at negative 4 and negative 2. Part of that. All right, so what you want to make sure you do here, I'm going to highlight this for this one. Make sure you put down here for the intervals, you give the x value intervals. All right, now let's go ahead and talk about typical types of graphs you will see in Algebra 2 here at the beginning. The typical types of graphs we'll see are listed on this chart. You will see linear, quadratic, absolute value, and constant. Now what these graphs look like, notice the linear graphs are lines. You're probably very familiar with these from algebra. When you were graphing in algebra, most of the time it was lines. But you did do some quadratics. This is called a parabola. A parabola, notice, is a graph that is shaped like this. It's got the U shape to it. It could be upside down. This just gives information about, in interval notation, about what the domain and the range is. Notice the domain is all real numbers because it keeps going on to infinity. This arrow means the x's keep going wider, and also means the y's are going up higher, okay? Just like this one, the x's are going wider as well as going up and down. But notice the y's don't go on this parabola below 0. So that's why you've got a range that starts at 0 and then goes off to infinity. Whereas the domain goes to negative infinity and positive infinity because it keeps getting wider. Same with this one. This is a V shape. That V shape is for our absolute value graph. Notice that the range is from 0 and above, so it stops, the y values stop at 0, and it goes up higher for the range, but the domain, it keeps going on forever in both directions. Okay, and then a constant, this is a horizontal line. So whatever number you're given, like here we're given y equals 1, it's just horizontal there. Notice it talks about the key features of it and the intercepts as part of that. that's something that you'll want to take a look through to get familiar with it, because we're going to do a lot with these 4 types of graphs. So just a reminder, as you think about these, we talked about graphing, we talked about interval notation and set builder notation, and then we looked at when things are positive and negative and how to list that in interval notation, and then also our 4 typical types of graphs for the beginning here of Algebra 2.